Hi, welcome to the guidance video of Mission 4, where we will be covering amplitude modulation, angle modulation, and radio digital modulation. To start off, we start with modulation. Modulation is any message, signal, or modulating signal modulates or change some parameter a carrier signal to produce a transmitted signal or modulated signal at high frequency for long distance transmission. Modulation can be split into two types: analog modulation and digital modulation. To make you understand more modulation, here is simple analogy. A musician playing a melody on an instrument. The musician is the modulator, the melody is the information signal, and the instrument is the carrier signal. By varying the play of the song, it is similar to how a characteristic in the signal is changed to and producing different types of modulation. The first type of the modulation is amplitude modulation or AM. It, it means is a method of adding information to a carrier wave by varying its amplitude. It mostly used in radio broadcasting and also in television. Next type is angle modulation. Angle modulation is a method of modulating a carrier signal by varying its phase or frequency according to the information signal. According to the definition, we can tell there's two types of, of angle modulation. The first is phase modulation, PM, and second one is frequency modulation, FM. Phase modulation is we change the phase and we mostly use in two-way radios or walkie-talkie, also used in radar and also in satellite communication. In frequency modulation or FM, we often use in radio broadcasting, wireless communication, and also navigation. After learning the analog modulation types, which is amplitude and angle modulation, next we will be learning the communication system. First, from the input, we will go to the modulator and then will be carried through transmission medium such as cable or wave. Then they will go to the modulator and then we will get our output.
Hello, I'm Mui Kaiser. I will be explaining for the part digital modulation. So, digital modulation is a conversion of digital data into analog signal using various modulation techniques in order to reach higher transmission efficiency. So, for digital modulation, we have three techniques, which is amplitude shift keying, frequency shift keying, and phase shift keying. Before we continue, here are some pre-knowledge that you guys have to know. The first is symbol. It means a data representation. For example, 1-bit data representation has two symbols, which is 0 and 1. Next is baud rate. It is the number of symbols transmitted per second, which is the unit of signaling speed. Public Switch Telephone Network (PSTN) voice channel with 2400 bauds is the maximum transmission speed. And the last one, bit rate. It is the number of bits transmitted per second. Okay, so first it is amplitude shift keying. So this is a modulation technique that represents digital data using the amplitude of carrier signal. The modulated output will have a higher amplitude when the digital signal is high. We also got frequency shift keying. Frequency shift keying is a technique that uses frequency variation to represent bits 0 and 1 in digital signal. When the digital signal is high, we will have frequency 2. When digital signal is low, we will have frequency 1 in the modulated signal as shown in the figure beside. Next, we also have phase shift keying. Phase shift keying is a digital modulation process which conveys data by changing the phase of a constant frequency reference signal. There will be a phase shift in modulated signal whenever there is change in amplitude of digital signal. I will be explaining to you guys two types of phase shift keying technique in the following session. The first one is binary phase shift keying. It transmits signal that store two symbols, which is 1 and 0, when it is transmitting 1 bit of digital signal. The phase of carrier signal will vary between 0 and 180 degrees when there is level changes in the information. Next, we have quad phase shift keying. It can be said is a better version from BPSK because a carrier of QPSK transmits 2 bits per symbol instead of 1, and QPSK have a phase shift of 45 degrees, 135 degrees, 225 degrees, and 315 degrees with 90 degrees phase shift each. It effectively doubles the data carried by a signal within the same bandwidth compared to binary phase shift keying. Okay, so this is the constellation diagram of quad phase shift keying. This constellation diagram is to simplify and represent QPSK. It is a complex plane with a real part in terms of in phase and imaginary part in terms of quadrature. From the diagram, you can see when the input is 0, 0, the modulated signal will be in a phase position of 45 degrees, and when the input digital signal is 1, 1, it will be in the phase position of 225 degrees. Okay, so next I'll be explaining a more improved modulation technique, which is quadrature amplitude modulation, QAM. What is QAM? QAM is a method of combining two amplitude modulation signals into a single channel. This approach will help to double the effective bandwidth. QAM technology is used mainly for wireless applications, for example, Wi-Fi, due to its transmission efficiency. Right, so here is an example of 8 QAM, which represents 3 bits per symbol. So from the diagram, we can see that it has two different amplitude, and each amplitude has 4 phase variation for each symbol. Based on the formula, number of QAM equals the number of amplitudes times number of phase. We have an 8 QAM here. A better illustration can be observed from the constellation diagram.
Next, we will look at recent advancement in the communication field, especially 5G. So what is 5G? 5G is the fifth generation mobile network. It is a new global wireless standard after 4G networks. 5G wireless technology delivers higher speeds, ultra-low latency, massive network capacity, and a more uniform user experience to more users. So what 5G will give to the world? In the economy aspect, 5G full economic effect will likely be realized across the globe by 2035 by supporting a wide range of industries and potentially enabling up to $13.1 trillion worth of goods and services. In business and industry aspect, depending on the industry, some businesses and industries can make use of 5G capabilities, the high the high speed that 5G is designed to provide. For example, small factories could use 5G to run industrial Ethernet to help them increase operational productivity and precision. In remote healthcare providers can access patient vitals and health data in real time or perform remote surgery when necessary. In pursuing 5G, there is some misconception in the society, which is the first one: electromagnetic field of 5G can cause cancer. Studies shown that it did not find a clear association between high-frequency EMF in 5G network with brain tumor possibility. Second misconception is 5G use more energy than previous generation. 5G antenna work on demand and only transmit data and when it is needed. And they also consume 10 times less per gigabyte transported, accommodating more users carrying 10 times more traffic. So that's the end of the guidance video. I hope you're listening and enjoy it. Thank you.